Now, if we see what exactly is the thing that is taking our time. So the time taking thing that is there is calculating the sum of left and right. So we are discussing approach 2 now. So at every index we were going left, we were going right. So that thing we can save. How we can save that is, imagine if I am going in array from left to right, left sum can anyways be calculated. First element has left sum as 4 has left sum as 0. Then 3 has left sum as 4. Now 1 has left sum as, what I can do is I can say this old sum I calculated and 3 is 7. Now 2 has left sum as, in 7 I can add the previous element. For 2 the answer is the old sum and the previous element. So what I'm doing is I'm creating a separate array. I'll call it a left sum array. What it is telling is, it is telling what is the elements on the left of any index, what is the sum of elements to the left of that index. So if I do that for entire array, I can build this. After 7 it will be 8, and 8 to 10, then 10 plus 7 17, and then 17 plus 9 26, and then 27. This is my left sum. Now what it is telling is, left of 0 has this sum, left of 1 has this sum, left of 2 has this sum. This is left of 0, left of 1, left of 2, left of 3, like that. Now similar way we can also calculate right sum, which will tell me what is the right sum of 6, then what is the right sum of this, but we need till 0. So what we can do is, right sum of 0 also we want. Yeah, so we can go, 6 has right sum as 0, 5 has right sum as 1. Now 4 has, index 4 has right sum as 10, index 3 has right sum as 17, index 2 has right sum as 19, index 1 has right sum as 20, and index 0 has right sum as 23. So these are the right sums of every number, right? Now looking at this, what we need to tell is, find an index in both these arrays, 3 4 5, and this is 5, this is 6, this is 7. We can loop over both these arrays and keep comparing left and right sum for every element. So if we see, 4 is an index where, if you see, the right sum of 4 and left sum of 4 is equal. So these two arrays are giving us this answer. That means left sum and right sum array, if we can build, we can come up with the solution, right? So in this approach, if we look at the time and space complexity once again, then what we did is, we created two new arrays, left sum and right sum, and their size has either been equal to this or one extra than this, right? Because for 6 we calculated left sum, the 7 is not needed here. So we needed an array of size 7 ideally, which is same as original array, where we stored left sum, where we stored right sum. So 2n is the space that we have taken. After that, what we did only one pass through the array to build the left sum. So when we went left to right, we were building the left sum array. Then we went from right to left to build the right sum. These things can be done in single loop also. So we are building left sum and right sum array. So we can say, like, let's say we are putting 2n time complexity. This is our space that we have used. Time is this way. So far we have spent 2n. One's left to right, one's right to left. After we have built these two arrays, then we are writing one more loop on these arrays where we are comparing every location. Left sum and right sum we are comparing. So there is a third loop that we are putting, which is sequential. So overall we are putting 3n time complexity here. So this is our next solution that we have come up with. Now let's think about, can we optimize on space also? Do we really need two arrays, or we can manage with one array or without array? So that is what is the next thing that we are going to discuss.